So in the previous lecture we have seen about cylindrical coordinate system, and already we have studied about rectangular coordinate system, or it is also called as Cartesian coordinate system. In the Cartesian coordinate system, what are the points we are having? In Cartesian coordinate system, or it is also called as rectangular coordinate system, in rectangular coordinate system we are having x, y, z. In cylindrical coordinate system and cylindrical coordinate system we are having r, 5, z, right? So for this we will be writing the position vector. Say for example, p is a vector which is having x, y, z, and here the p is a vector having r, 5, z, and here the p vector will be written as px ax, or you can also write as directly x ax. Okay, why I am writing here? Because py, pz, az, here the position vector will be written as pr ar plus p5 a5 pz az. Okay, why I have written like PR? Because PR is the radius, P5 is an angle which is also called as azimuthal angle, and Z is that point which is same in case of Cartesian and cylindrical coordinate system. It is just comparison, and it's easy to remember the things. Okay, here the base vectors will be ax, ay, az, which is with a cap. Here the base vectors are AR, A5 and AZ, right? So next, what you are going to consider? Let me take here in this you have written how to find out AX. You already got this. AX is nothing but it is P divided by position vector P divided by the what it is, magnitude of P, right? It is same in case of cylindrical coordinate system. Next, the important thing is differential elements, or the differential elements in both systems, differential elements in both systems, which is very important. DL, that is a differential length. So what is a differential length in case of Cartesian coordinate system? It is dx ax plus dy ay plus dz az. Okay, dz az. But in case of cylindrical coordinate system, the differential element or the differential vector is written as, first is dr ar is a length. Yes, it is going to be length itself. When you are talking about length, you cannot consider the angle, but you can write it in by taking angle and you can convert it into length, that is arc length. You can write arc length. So d5 is angle, a5 is a direction, but you cannot mention angle for a length vector, so it has to be converted, that is rd5. rd5 is nothing but arc length with an angle of 5. So dz. So don't get confused. When it is angle, you cannot write it for a length, you have to convert it into length. So that is called as arc length. With the help of r, if you draw this, if you draw the cylindrical coordinate system, then how it is r d5 is obtained, that is going to be more clear. But for your exam point of view, that is not necessary. The derivation, how exactly the arc length is obtained and all, is not at all necessary. You have to remember, for Cartesian coordinate system, dx ax, dy ay, dz az is a differential length vector. For cylindrical coordinate system, dr ar, dz az are directly the lengths, so you can write it the coordinates which are given in the formula, but r d5 has to be converted. 5 the middle, here x, y, z is given and the differential elements are dx, dy, dz. Here R5z will be given. The differential elements will be dr, d5, dz. d5 is a angle, there is a shift in the angle, displaced the shift in the angle is again is going to give you an angle. So you cannot write it angle. What you have to do, you should convert it into arc length. Okay. So the next is the magnitude of dl is dl magnitude. What is what? Dx square plus dy square plus dz square. Similarly, dl magnitude, which is, yes, dr square plus r d5 square, r d5 square plus dz square. This is magnitude. Here in case of a Cartesian coordinate system, dv is dx, dy, dz. It is multiplication of all three coordinates. Here in case of cylindrical coordinate system, it is again the 3 points dr and d5. d5 you have to write it r d5. So I am writing it in initial stage, that's it, r d5 and dz. Okay. Next comes the differential surface area, ds. See, when it is mentioned along with normal direction or to which axis it is normal, you just have to exclude. If it is dsx, what does it mean? That is differential vector area normal to x direction. So how you have to write for dsx? You should write it as dy dz, which is normal to x axis. Similarly, try to write this for dr. dr, can anyone tell me? Sorry, differential surface area is a vector quantity, differential volume is a scalar quantity, not differential. It is volume is scalar quantity, surface area is vector quantity. So dr, ds, differential surface area normal to r direction. So what you have to write? First thing you got to know that it is normal to r direction. So write it ar, it is done. Skip dr, rest things are d5 and dz. Okay. So it is r d5 dz. It is r d5 and dz. Similarly, we'll write dsy. We'll write dsy, which is d. Yes, what you have to write? It is normal to y direction. So which are the other 2 points you have to write? dx and dz. ds, dx and dz. The right format of writing this is dz, dx, dy. Okay, because there are two types of coordinate system, a Cartesian coordinate system. It is right-handed coordinate system and left-handed coordinate system. When you are considering one particular point, you can't move like to and fro. You have to follow the sequence x, y, z, y, z, x. Okay, z, x, y. That is the circular shift, circular flow. Next is ds5. ds5. That is differential surface area normal to 5 direction. So skip 5, the left is dr and dz. See, this is the logic I am telling you to remember the formulae. Okay, this is the logic I am telling you to remember the formula. This is not the mathematical derivation. Okay. Next is dsz. dsz, what you have to write? That is the differential surface area normal to az direction. First point is done. Then eliminating z, what you can write? X, y. Similarly, it is, yes, it is same for both the coordinate system, that is dr, d5, it is not 5, sorry, it is z, it is az. So for d5, what is the d5 along with r you have to write, because it is arc length I am talking about. Okay, this is very important column that you have to remember, very important to remember, and it's very simple. If you remember it by logic, this is very simple. Okay. Now this is about the formula. Next is when you are going to solve some problems, there you may find the challenges, because now you have studied the Cartesian coordinate system as well as the cylindrical coordinate system. When the points given in such a way, in such a system, like where one point lies in Cartesian coordinate system, other point lies in cylindrical coordinate system, that time you have to convert either of the coordinates into a same coordinate system. For example, if one of the point P, okay, one point P is given in x, y, z, and other point Q, it is given in R5Z. So you should convert these into, it is Cartesian coordinate system, this is cylindrical coordinate system. Okay, either you have to convert Cartesian into cylindrical or cylindrical into Cartesian coordinate system. So there is a derivation which is not necessary for your problem exam. So just directly write down the formula how you have to get. If the points are given in cylindrical coordinate system, R5Z are given, so how to find out x? X can be written as R cos 5, R cos 5, R cos 5 is a x. Y can be written as R sin 5. Z is same for both the direction, sorry, both the system. Similarly, when the points are given in x, y, z or in the Cartesian coordinate system, how to convert it into R5Z? Okay, now it's very simple. Can you tell me like how to get R now? R is nothing but, it is under square root of x square plus y square, okay, where phi is tan inverse of y by x and z is same for both the coordinate system. This you have to remember this. It is very important because in exam they may give you, they may confuse you by giving 2 points in different coordinate system. Only thing is you have to convert it into either of the coordinate system which is convenient for you, then you can proceed with the solution. Okay. This is regarding cylindrical coordinate system and Cartesian coordinate system. The next coordinate system we are starting with circular coordinate system. The next is third coordinate system, circular coordinate system, circular coordinate system. Okay, see, just try to, I'll write the coordinate axis or the points. You just have to remember, or you just have to try to recall what are the coordinate points in other coordinate system. Okay, so here R phi theta. 3 points here are R phi theta. In cylindrical, I'll write it as rectangular only to make it simple. RCS, that is rectangular coordinate system, then is cylindrical coordinate system, and then is circular coordinate system. Here x, y, z are the coordinate points. Here R5 z are the coordinate points. In this R5 theta are the coordinate points. So there is a range for R and phi, sorry, here it is theta, the new term theta. It is not necessary to define all the terminals here, just understand what exactly it is. Infinity to infinity, okay, sorry, it is 0. R is greater than equal to 0 less than infinity, then theta ranges between 0 to 2 pi. okay, sorry, phi, and theta ranges from 0 to pi, it is half angle, half angle, okay. Phi is azimuth angle. Now if you want me to draw this, I will draw, but it's going to be confused for you. So better try to remember r, 5, theta are the three coordinate points in circular coordinate system, which ranges between r ranges from 0 to infinity, phi ranges from 0 to 2 pi, theta ranges from 0 to pi. Okay. So what are the base vectors in this coordinate system? Yes, the base vectors are similar to the other two coordinate system. Base vectors are AR, A5, A theta. Okay, AR, A5, A theta are the base vectors. Next, what we have studied in other two coordinate points, that is differential elements. Differential elements, one is differential length, other is differential volume, and the differential surface area. Observe carefully, for length and differential surface area I am marking it as a vector, for volume it is scalar. Okay. Here first you should convert A5 and A theta, because as I already said these are angles, but these has to be converted into lengths. So how it is going to be written in a length, that is A5, A5 means that is D5 and D theta. Okay, D5 is R D theta, you should remember this. If any one of you wants how exactly it is r d theta or r sin theta d5 for, it is d5, it is d theta, okay, r sin theta d5. So how these d5 is r d theta, d theta is r sin theta d5, if any of you want to know, definitely I will take, just you have to comment in a comment box so that I can take a separate lecture, separate video on this and I can upload. Okay. So for time being you just have to remember, in cylindrical coordinate system, in circular coordinates, sorry, cylindrical coordinate system, d5 is written as r d5. In circular coordinate system, d5 is written as r d theta, d theta is defined as r sin theta d5. Okay. So now you can write dl, right? Dl is nothing but it is, yes, it is drar plus d5 a5. What is d5? d5 is r d theta, a5 for an direct for the direction. Then is d theta, d theta is r sin theta d5, r sin theta d5, it is in the direction of a5, it is in the direction of a5. Okay. So it is, don't get confused, I will make it, it is d theta, it is d5. So I have written it wrongly here, it is r d theta a theta, it is, this is for a correction I am writing, and it is a5. Okay. Next is volume. So volume is multiplication of all the three parameters or the differential elements. So dr is as it is. Next is d theta. D theta is r d theta, and the next one is r sin theta d5. So you can write it as r into r square sin theta dr d theta d phi, r square sin theta dr d theta d phi. And the differential surface areas, differential surface area normal to r direction, differential surface area normal to theta direction, differential surface area normal to phi direction. So the same logic, use the same logic. You want to write it for a r direction, normal to r direction, and skip r here. You have to write for d theta and d5. d5 is r sin theta d5. So what it is going to be? It is r square sin theta d theta d phi ar. So for differential surface area normal to theta direction, what you have to write? Theta as it is, or the normal to theta direction you mentioned, and eliminate the theta element here. So what? dr is present and d theta you have omitted, written d phi. You should write r sin theta d phi, r sin theta d phi. So what you can write here is r sin theta dr d phi in the direction of a phi. In the direction of a theta, not a phi. Okay. Next is, next in the direction of a5 you should write, right? For a5 you have to write so for a5 what it is going to be written? Okay, eliminate phi. So r sin theta d phi is eliminated, left with r dr and r d theta, right? So it is written as r dr d theta a phi. Okay. So try to relate all the concepts or all the differential elements, how to write. I'll summarize the 3 coordinate points later. Okay. Now similarly, as you have studied, when that points are given or when you need to convert it into other coordinate system, you have already studied for Cartesian coordinate system and for cylindrical coordinate system. Now the same problem or the same concept, the relationship between Cartesian and spherical coordinate system, rectangular coordinate system to circular or spherical coordinate system, or spherical coordinate system, spherical coordinate system. So directly I'll write for x, y, z. What are the formula? For x, y, z. For x it is r sin theta cos phi. For y, r sin theta sin phi. For z it is r cos theta. Okay. Similarly, for r phi theta, r phi or r theta, it's a sequence, r theta phi, r theta phi. R theta and phi. So r theta phi, r is square root of x square plus y square plus z square. Phi is, it is theta, right? Theta is cos inverse of z divided by under the root x square plus y square plus z square. Okay. For phi it is similar to the previous cylindrical coordinate system, that is tan inverse of y by z. This is about spherical coordinate system. Spherical coordinate system. Let's draw a chart for this. This is coordinate system. Here differential length, differential volume, differential surface area. For a rectangular coordinate system, for cylindrical coordinate system, for spherical coordinate system, what you will write for dl is equal to dx square plus dy square plus dz square. Okay, because here the, let me take p as x ax plus y ay plus z az. Here the p is pr ar plus p phi d a phi plus pz az. P is equal to here pr ar, but here don't get confused that both the are same here. You can take it as row also. In some in one in different textbooks it is considered as row, just to avoid the confusion, because here the r is ranging between 0 to infinity. Okay, r is not, r is ranges between 0 to infinity. So plus next p theta d theta a theta plus p phi a phi. Okay, so for differential volume, in this case for Cartesian coordinate system it is dx dy dz multiplication. Here you are going to write three areas. dsx is dx dy, right? For dsy it is dy, sorry, dz dx, dsz is dx dy is dy dz, dx dy. Similarly, make all the charts, maintain a chart here so that it is easy to remember. Keep it in, write it in a sheet. Whenever you sit to solve the problems, you have to keep the sheet. So it is going to be very helpful. Okay. Okay. Next important thing is a dot product and cross products of vectors, because when you want to transform the vectors from one coordinate system to other coordinate system, there you will come across the multiplication of two different unit vectors. For example, when one vector is given in Cartesian coordinate system, the other vector given in a cylindrical coordinate system, when you try to multiply both the vectors, scalar quantities or the numericals, you can directly multiply, but when it comes to the direction or AR and AX, that time, that you have to understand the cross product and dot product. That process is nothing but that is application of dot and cross product. So that is very important to solve the problems. So what you have to write, just I'll not take in detail, I'll just give you a chart table so that it is more comfortable to remember. Okay. Transformation of vector. Take it as transformation of vector. What I told you is, when A is AX plus AY plus AZ. Okay. The same vector or vector AR plus A5 plus AZ. When you want to multiply these two vectors, okay, so what happens is, say for example, you have to find out how you will multiply AR. You just have to get AR first. AR. To get AR, vector A dot AR. To get A5, vector A dot A5. To get AZ, vector A dot AZ. Okay. So here what happens here is, I'll take only AR, what you will write, A vector A into AR, right, dot, it is not into, it is dot. So how will write AX, you have to write the vector A in Cartesian coordinate system plus AY plus AZ dot AR. Okay. Now AX dot AR, AX dot AR plus AY dot AR, AZ dot AZ. Now these two are the unit vectors. Okay, hope you know about dot product. Yes, you all can understand what exactly the dot product. A dot B is nothing but, yes, how can you represent A dot B? That is vector A into vector B into cos theta, right, cos theta. AX dot AR, you should know the angle between AX dot AR or what the component might be. When it comes to ax dot ar, okay, ax dot ar, I'll give you this chart now, this table which is helpful. Okay. Now you will understand how this chart is helpful. A dot product I am talking about, right? Dot product for ax, for ay, az, ax dot product with ar, a phi, az. Ax dot ar is cos phi. Ax dot a phi is minus sin phi. It's all having the derivation but which is not required. Okay. Ax dot az is 0. Ay dot ar is sin phi. It is cos phi 0. And az dot ar is 0. Az dot a phi is 0. It is 1. So, what you can write here, therefore, AR is equal to AX dot AR is cos phi. So, AX cos phi, AX cos phi plus, it is not vector, plus AY dot AR is sin phi plus AY dot AZ is 0. Therefore, AR is AX cos phi plus AY sin phi. This is your AR. Similarly, you should convert it into for A5 then AZ. Okay, A5 and AZ. You have to remember this. As and when it is required in problem, you will understand and you can easily apply. Okay. The next table, it is to convert spherical cylindrical Cartesian coordinate system vector into cylindrical coordinate system. The next table is to convert Cartesian to spherical. Next to Cartesian coordinate system to spherical coordinate system. So, the dot products, what are the coordinates? Ax, Ay, Az, and what are here? Here it is Ar, A theta, A5, these are vectors, these are cap, which is very important so that you can easily understand. Now, Ax dot Ar is sin theta cos phi, sin theta cos phi. Ax dot A theta is cos theta cos phi minus sin phi, sin theta sin phi, cos theta sin phi, cos phi, cos theta minus sin theta and 0. So, this is to convert from Cartesian coordinate system to spherical. One more combination is left, which is that? Okay. Now, so remember all these points. Okay, remember all these, and in the next class we will solve some problems based on this chart. We'll take a simple problem now. Okay, let me take obtain. Yes, we'll take one problem. First one, obtain the spherical coordinates of 10 ax. So the given system is given vector is in Cartesian coordinates at a point x equals to -3, y is equal to 2, z equals to 4. Solution, what you should find out? You should find out you have to convert x, y, z into r, theta, phi, because what is the question? Obtain spherical coordinates, okay, spherical coordinates of the vector 10 ax. So the given vector is, let me take f is a vector which is 10ax, okay, 10ax. Now fr can be obtained. Yes, how to find out fr now? Fr can be written as it is, just a minute, okay. So what we have to find out? We need to find out r, phi and theta, right? So fr is the first component we should identify. What is the fr? That is f vector dot ar, right? So what is f? That is 10ax dot ar, ax dot ar, that is Cartesian which table you should refer here? Ax dot ar, which table you should refer? You should refer to the table converting from rectangular coordinate system to spherical coordinate system. So ax dot ar is sin theta sin phi, sin theta cos phi. So 10 ax dot ar is sin theta cos phi, right? Now this is fr. Can you identify f5 and f theta? No, because here 0, 0, these two are 0, right? Multiplied with anything is 0. So your vector in spherical coordinate system is 10 sin theta cos phi. Vector is transformed. Now what you have to identify is, you know that x is, I am talking about the coordinates, previously we have written x is here. How to write x for coordinate system? Just a minute. Yes, for x it is r sin theta cos phi, y is r sin theta sin phi, z is r cos theta. You should write that. So now you already know x, y, z. What you need to find out? You should find out r, theta, phi. So what is r? What is r? R in case of okay, just a minute, we'll take it x, y, z, okay. So what is x? X is r sin theta cos phi, y is r sin theta sin phi, z is r cos theta. Okay. Now phi is, what is phi? Phi is tan inverse of y by x. So tan inverse of y by x, y is 2 and 2 by minus 3, which is minus 33.69. So when it is minus, you should add 180 degrees because x is negative, y is positive, hence y must, phi must be in third quadrangle, that is 90 to 180. It is, so it should be in second quadrangle, 90 to 180. So phi must be minus 33.69 plus 180 degrees, which is equal to 146. When one of the angle is negative, x is negative, then you should add. Okay. Therefore, cos 5 is minus 0.832, sin phi is 0.5547, and theta, what is theta? Theta is cos inverse of r by z, sorry, z by r. Cos inverse of z is how much? R cos theta, yes. Four divided by x square under root plus y square plus z square, because r is under the root of x square plus y square plus z square. These are all formulae I have given, you should find out. Cos inverse of 4 divided by minus 3 square plus 2 square plus 4 square, so that gives you 42.03 degrees, that is theta. Okay, that is theta. So cos theta and sin theta, you should find out cos theta and sin theta. Cos theta will be 0.7428 and sin theta will be 0.6695. So what is FR? FR is already find out, that is 10 cos theta and cos phi, right? What was the FR? FR is 10 sin theta cos phi. So F theta is 10 cos theta into cos phi. F5 is 10 minus sin phi. So substitute theta and phi values, you will get FR, F theta and F5. You can write along the direction. Okay, I'll take the same problem in the next lecture. Okay, but to understand this problem, why I have given it roughly, because where exactly you will use the tables and the formula which I have given today. If you study those things today, then tomorrow's session will be easier for you and you can understand the problems. It is not the final one I have taken the problem, just I am giving you the hint where, from where or how to use the given tables. So which is very much important to remember and try to write it logically. Okay, we'll see you in the next session.